Apparently, my recording stopped. Luckily, I don't have much more, but if memory serves, I think it was 3 times 1 x to the 1 minus 1 um, times y plus, uh, yeah, plus 3 times 1 times y to the 1 minus 1 times dy dx. And with that, we also have a. I'm trying to remember. Was it plus y squared? Yeah, it was plus y squared, right? So it'll be plus 7 y squared prime, or, you know, since we're calculating it out, it'll be plus 7 times 2 y2 minus 1 if n is equal to 2. And then almost forgot the most important part. That'll be multiplied by dy dx. And that's, of course, meaning that d of dx, like the derivative of 7y squared with respect to x, is the same as the derivative of 7y squared with respect to y times dy dx, being some arbitrary derivative of y with respect to x, which we are trying to find. Okay, and all of that is equal to 3 minus x cubed prime, since our 3 is a 0 when differentiated. We will have minus 3 times x to the 3 minus 1. If n is equal to 3, we bring that to the front, and then we have n minus 1. Now, let's evaluate this. Anything to the power of 0 is going to be 1. So we have 3 times 1 times y, which is 3y, plus, same thing, anything to the power of 0 is 1, so we will have 3 times 1 times, oh, almost forgot. There is a 3x there as well. It'll be 3x times y, 1 times y to the 1 minus 1. So there will be 3x dy dx plus 14y. 2 minus 1 is 1, and 7 times 2 is 14, so we'll have 14 times y to the 1 times dy over dx, or the derivative of y with respect to x, minus 3x squared, 3 minus 1 being 2. Now, what we can do is we can factor out this dy dx from here. It'll be 3x plus 14y dy dx is equal to negative 3x squared minus 3y, and we can divide this by 3x plus 14y and divide this side by 3x plus 14y as well, meaning that if we cancel both sides out, we will have the derivative of y with respect to x as negative 3x squared minus 3y all over 3x plus 14y. Now, if that's at all confusing, it's totally fine. Implicit differentiation is pretty complex. After all, it is a big part of multivariable calculus in the future. And while this wasn't meant to be some super intensive explanation of what implicit differentiation is, I hope this does open your eyes to the fact that maybe immediately trying to define y as a function of x might not be the best thing to do, and it might actually aid your calculations to keep y as an implicitly defined function of x. Okay, so yeah, that was probably most of what you'll need to know if you are taking an introductory calculus course. That will be mostly what you're going to need to apply in terms of derivatives. And I mean, there's obviously more stuff that I could have talked about. I could have talked about like the derivative of a to the x, like some a being some constant, or the inverse trig functions like arcsine, arccosine, and I could have done that, and I most likely will, but I hope this does um, maybe show you where some of the very common derivatives that are throughout your calculus homework come from. And I won't kid myself and say that this was like a great video or anything. I mean, it was kind of constantly hounded by human error, and I don't have the greatest handwriting when I'm writing with my finger, but I do hope that you learned something, and if you did learn something, please comment down below. Uh, if you did not learn something, constructive criticism is always encouraged, and if you're not in the mood for constructive criticism or a comment, then I don't know, you can do some jumping jacks. And also, this occurred to me a little while ago. We've been together, like, doing this stuff for a couple hours now, and you are no doubt tired if you managed to watch all 3 hours of this, which, if you did, kudos. I can't. But, yeah, I think you might need something to relax with, and I thought I might as well give some music recommendations. I feel like now we're friends because I've been talking to you for longer than I probably should be. So, if I were to give a good way to relax, that is Modal Soul by Nujabes. It is a fantastic chill jazz, almost trip hop record by one of my favorite producers of all time. Has some fantastic features, and if you do listen to it, please comment down below. Okay, I think that'll be it. You can also, I feel like I've said comment down below quite a few times now, but you can tell me what video topics you want covered in the future, and that'll be it. Okay, bye.